Hello! So in this video, I'm going to show you how to wrap a gift, which can be a Christmas gift or birthday gift. So without further ado, let's jump right into it. So first thing first, what do we need? Of course, we're going to need the gift. Also, we're going to need the gift wrap. And you're also going to need Tylenol, just in case you're suffering from trying it for too long. And you're going to need tape and tape measure, and a piece of pen and paper, a piece of paper and pen. And also you're going to need one Asian friend. You'll know why later. Now that we have everything we need, our next step is to figure out how we should cut out the gift wrap. Well, we can solve this problem easily with AI or machine learning neural network. So our first step will be measuring the dimensions of the gift. We'll go with length first, and then the width, and then the height. And then we write down those measurements. So for the length, we have 13.5 inches, and for the height, we have 5, and for the width, we have 3.5. Since we only have 3 dimensions, and there's only one value for each dimension, that makes this problem a lot easier to solve. Because we don't need imputations, since there's no missing values, and we don't need cross-validations, because there's only very limited datasets, and no need normalization, because we want to keep the original value to measure the gift wrap. And there's no correlation between those dimensions, so we don't need to do any PCA also. Yeah. So we're going to go ahead, skip all that, and move on to the next step. Now just a brief introduction of neural network. So neural network consists of 3 or more different layers. So we have length, we have height, we have width, right? And then let's say there's also a hidden layer. So this is going to be our input layer. And there's also a hidden layer. Let's say there are 4 nodes in here. And output, we're going to need 3 nodes for the output. So let's draw 3 nodes here. And this is going to be our output. So there are going to be a bunch of connection here. So in the output, we're going to have our expected value for our different dimensions. So let's label them L apostrophe, H apostrophe, W apostrophe. Okay. So now we have our inputs value from each measurement, and then we're going to need to apply weight on each input, and then use a formula for y equal to mx plus b, where the m is going to be our weight, and then b is going to be our bias. I'm going to use this formula to calculate all the nodes in the hidden layer, and from the hidden layer to the output layer, we're probably going to use the ReLU function. All right, since we want to keep the original x value, so that goes from max of x, and the graph will be like that. And we don't need to add a dropout layer, since we don't need to avoid overfitting. Actually, we won't want overfitting. So with those measurements and those formulas, we should be able to get expected output. Then we'll use the backpropagation to loop it backwards. With the gradient descent, we should be able to find a optimized m and b. With those optimized numbers, we should be able to get a best output numbers. So let's assume those are our optimized dimensions values. We're going to evaluate those outputs and see how well the model was trained. And the algorithm here we'll be using is SSE. And the formula goes SSE equal to the sum of the errors. So it goes from 1 to n, the actual value minus the expected value, and then square. And then once we plug in those y values in there, we'll get a number. Let's say we get a number of 2.3. This number will be our loss. So the smaller this number is, that means the better our model is. Now what does all that have to do in our case? Nothing. Now that you're completely confused, great. Now we will start wrapping up like a normal person. Now that, my friend, is how to wrap a gift. This video is for entertainment purpose only, so please don't use this for educational resource. Well, you can. Hope you enjoyed this video. Please don't forget to like and subscribe. Catch you next time. Best of luck. What should I say? What should I say? Hey, what should I say? What should I say? Hey, yo.